All right. Good morning. Welcome, everyone. Actually,
Welcome.
it's only morning for, I guess, Ross and I. Mark, it's not your morning.
Yeah,
It's happy hour
Welcome
time.
to It's Happy Hour for Mark, truly. It's actually still coffee time for Ross and I. Welcome, everyone. I'm David, developer advocate at Balena. Over on my, nope, that side is Mark, another of our developer advocates, and we have a new face down below us down here. Ross, you want to say hello and give a quick welcome, an intro?
Hey, it's fun to be here. This is actually one of the ways I first learned about balena a long time ago was by watching the IoT Happy Hour. So it's fun to be on the show now. I'm a technical sales lead, so I get to spend a lot of time with customers and hear what their needs are and so forth. So that's just quite germane to our topic today. And what is our topic today?
Awesome. Well, today, one of my favorite topics is, you guys probably already know, we are going to be talking about device types, how to choose the right hardware for your IoT project. So I have an array of single board computers on my desk ready to go. Ross, I have a strange feeling you do also. Mark, we'll take a look at what's on your desk in just a moment. But before we get into that, let's do a quick shout out, as we usually do, to see what job openings are currently posted.
Hiring. Let me share the link on the.
Okay, if you want to do that,
chat.
Mark, I will bring up the. Let me see if I can do screen sharing, and I should have one ready to go. There it is. All right. So I think it may be the same as last week, actually, but it looks like we've got, are you the future maintainer of Etcher? So if you've ever used Etcher in the past to flash your SD cards or USB sticks, and you're familiar with the application and you enjoy open source, definitely have a look at that one. Security engineer and front-end engineer have been posted for a little while now. I think we've talked about those in the past. And of course, design your own role. You tell us what you bring to the table and what IoT skill set you've got, and we could take a look at that. Right.
Yeah, looking forward to know the next design your own role.
Yeah. Ross, you mentioned earlier that one of the ways that you found out about balena was from right here on IoT Happy Hour. Yep. Now, I do have one very quick question. You seem to have way too much on your walls. As you can tell, Mark and I, we like to keep a very clean look on our.
It's impressive. That's right. Yeah.
So we're going to have to work on getting some of that, taken off of the walls. But that's an opportunity.
I don't know. It's sort of real life. It's genuine.
Like it.
Okay.
That's
it's normal.
All right. Well, you know what?
You guys
Mark, maybe we should hang some stuff up. Maybe we need some things on our walls.
The thing is that you don't see my floor, so that's
that's all down there. All right, you guys. Well, let's.
But maybe the question here, David, is what episode did you watch first? No.
This is true.
What was about that?
I don't know if I remember the first episode that I watched, but I watched some of the early episodes for sure. And of course, I knew about Etcher at that point too. So I felt informed actually about this. It was
awesome. We have a comment already rolling in. Wait, is that a "What's on your desk" shirt?
Yeah,
it sure is. And yes, I shot JR might need one of those. He's got stuff on his desk. AB, did I change my sitting arrangement? Yeah, I'm in my wife's office today. I don't know particularly why. I've been down here for a couple days. I just needed a little change of scenery. I don't know if I really like it though. But okay, so let's do this. We are going to be talking about device types. So I'm going to go first for what's on your desk. Mark, should we go with the Christmas jingle, or do we want to just keep it regular?
Maybe Ross can choose.
Ross can sing it himself, or he can choose.
Yeah, I will choose the Christmas jingle. Well, actually, what are my options here? I didn't know there were choices. So,
there's only two choices. Your
Okay.
choices are Christmas jingle or regular jingle.
let's go for Christmas jingle.
All right,
It's not
sure.
the
I mean,
season, so it's interesting.
It's May.
Yeah.
Why not?
Yeah.
Mark, you
All
want
right.
What's on your desk?
It's still
It's amazing
rolling.
that someone
that
is
one.
always laughing.
Still rocking that one in May. I don't know. We need to get Chris. It's been a while. We need to get him on here. Maybe record a new one. Summer remix. Yeah, I think it's probably time to get a new one. We can make that happen. All right.
I was watching the Etcher Pro episode. That was the first of the year. And we agreed on that episode that we can say Happy New Year during all 2021. But yeah, we don't remember that.
Happy New Year. Yeah, I had forgotten about that.
All right. I don't know if we will do the Olympic record of what's on your desk today, but I have nothing new on my desk, so all yours, gentlemen.
All right. Well, mine is basically devoted to the topic for the day. So we can take a quick glance. Let's switch cameras to blurry cam.
Let me change this
TM.
for a sec.
And like I said, I'm downstairs at my wife's desk, so it's a little different setup. So I'm a little unorganized here. But
this is unorganized.
Yeah, well, yeah, this is. Well, I just had to collect some items and bring them down here. So we're going to be talking about and sort of dive into the prototype to production workflow. So some proof of concept, some hardware that gets you started, and then we'll kind of segue from there into really scaling up, going to production. We'll talk about budget. We're going to talk about workload that you're going to be running, the various use cases. So just sort of going around, I sort of chose a variety. So we can talk about tiny little devices. If your use case, blurry cam is extra blurry today. There it goes. So this thing is a tiny, tiny, tiny little device. It does, have one Ethernet, one USB, and, a couple of pins, but it's obviously not quite as powerful or offer the same expansion capability as something like a Raspberry Pi. This is actually a Rock Pi. I also have the Nano Pi Neo in the same exact format. I forget what the millimeter dimensions are.
Right?
Yeah, very similar. This one uses a different SoC, but I've got the Nano Pi, the Rock Pi, the Banana Pi, the various, insert your favorite fruit Pi. I have our Jetson Nano here. We'll talk about that. I have this big carrier board here for a Raspberry Pi 3 compute module. And again, we'll talk about prototyping, right? Look at the sheer quantity of pins GPIO on it. 4 camera, 2 camera, 2 display, all breakouts here, UART on it as well. So again, prototyping only, and we'll get into that. But so this is a Pi 3 compute module IO board. This is built by Waveshare. I have our balena fin. We can cover that later. I have a Raspberry Pi. We can cover that later. And I have a pair of x86 devices as well. This one is from AD Link. We've had this one on the show before. We've had Paul talk about this device. But again, Paul Wheels from IoT North. So, we can cover workloads for that later as well. But anyways, a good sampling, at least I think a good sampling to...
bunch of
Yeah.
single-board computers on your table. We have a question from George JR. I think it's related with the Compute Module 3. Yeah, the expansion board.
Yeah, those are jumpers.
Wow.
In fact, without LED jumpers, key press, there's keys. You have buttons over here as well. I'll get the link to this in a bit. I mean, it might be a little outdated at this point, being that it's a CM3 as opposed to a CM4, but they're still pretty popular. So yeah, I'll grab the link to that in just a moment. All right, come back over to me. And Ross, you have anything interesting on your desk?
I might have a few or 8 SBCs on my desk, but we'll get to those as part of the regular show.
Okay, sure. Save them.
Including the one I'm not sure you've seen before, so this should be fun.
Oh, awesome.
The other thing on my desk that's good for now is we have a Balena Sound device. So you all know about Balena Sound. So the app that you can download, and I decided to build one that has speakers inside. So it's laser cut cherry.
Wow.
And
what on earth?
Just a Pi in the back.
Wow.
Yeah, and anybody can do this. It's super easy, right? Because it's a robot that does the work and cutting the pattern.
Okay, so it runs Balena Sound. We've talked about that project. We've built that project live in the past. That casing that you built for it, though, that appears to be all custom. So did you do, I mean, is that custom woodworking there? Is that laser cut?
No, I'm far too lazy for that. This is all done by a robot. So I designed it.
Okay.
But it's laser cut. So if you've seen a laser cutter before, it's really just a small robot that moves a laser around a piece of plywood and cuts all this. So this began life as a piece of plywood, piece of cherry plywood.
It costs a fortune right now to purchase that.
It's a little more expensive, but you can actually, like, if anybody's interested, you can have the pattern and you can just send it off to a online shop that does laser cutting, and you get the pieces of wood in the mail, right? And you can put it all together. So nice and easy.
We may have to get that posted on GitHub in the repo then, if it's not already there.
There you go. And this is what it looks like on the inside. So it's got a pair of beefy speakers, but they're USB powered. They sound, they're 2-inch, so they're not like, you're not going to run a party with these, but they'll fill a room kind of nicely. And
that's not the purpose. It's not a high fidelity. Yeah, I get it.
It just plugs in, so it's super simple on the inside. There's no amp in here because the amp is built into the USB powered speakers, and it's all running off USB-C power. It's Pi 4 in there and stuff. So it's remarkably simple, actually.
Got it. You already have your first customer. He's ready.
There we go.
Awesome. AD says it's a beauty. Okay. Well, I think in that case, Mark, you said
have more behind you, Ross, of those, because I see 3 like different.
Yeah, Ross, the shelf right above your head.
Yeah,
up behind you. Yeah, right there. There's more of them.
I've been experimenting with this sort of stuff for a while, so I've got various iterations and things that I've tried, old school looking radio type things and so forth. But this one that I just showed off is specifically for Balena Sound, so everything just fits nicely in there and so forth. So,
love it. Very cool looking. Okay, Mark. Well, you said you're going to skip, right? So,
I'm skipping. Yeah.
I think we are good to get started then on the main topic of the day.
Yeah.
How to choose a single board computer for an IoT project. Russ, do you want to sort of kick us off for the discussion? Obviously, all of us will be contributing, but you want to give us a little framing of kind of where you're coming from, or some thoughts on the topic?
Yeah,
sure. So the good news is that Balena supports about 70 device types right now. And the bad news is that Balena supports about 70 device types right now. Right? So you've got all these choices, right? And just the IoT world expanding, which is great, right? So you have all these things you can choose, but it also makes it difficult to know what to use in which circumstance. So we're going to try and roll through some of those, much like I do with some customers, and say, okay, we want to do this, or we've gotten started with this prototyping, what do we do next, and so forth. So we'll just roll through some of the things that David's done with customers and I've done with customers as well. So we'll talk about things you can develop with and do basic prototyping with versus things that you might want to get when you're ready to go to a fleet of 1,000 or 10,000 devices. And we'll talk about the kinds of devices that you might use for particular use cases. You know, if you're doing some machine learning and inferencing on the edge, there are certain device types that we have that are a wide number actually that are really good for that. We'll talk about different kinds of compute loads that you might have and devices that are good for that. So we're going to try and take you through the choice process in general today and show you, I mean, this is intended to be useful, but also to be fun, right? For David and I to show off all the devices that are sitting on our desk right now and say, hey, look at this one.
Yeah, absolutely. So let's start off. I'm kind of thinking, you know, you talk to customers on literally a daily basis. I know that you've mentioned one of them in the past by the name of Infarm. And I thought maybe it would be good to sort of share their story or a little bit about how they use balena and what their, you know, let's kind of talk about a product.
Yeah.
But really at the heart of it is a, you know, single board computer that is doing all of the orchestration. Do we have any pictures of what they...
Let me share what's the infarm product.
So okay.
Supermarket.
Right. So
maybe, Ross.
Yeah.
So if you like fresh herbs and fresh vegetables, you might like Infarm. So what you see in front of you now is one of their micro farms that's inside a supermarket. They have about 1,000 of these, probably more now, distributed across the world in supermarkets and restaurants and other places. And the vegetables and the herbs grow right inside that case in the supermarket. So it doesn't get much more local than that. When you want to go buy some fresh mint or fresh basil, it was grown right there in the store, might have been picked earlier that day, and so forth.
Yeah, I'm going to drop their URL into chat as well.
So they are based in Germany, and they have these micro farms spread across the world. So they've got some, which is pretty normal actually for our customers to have this widely distributed fleet. But now if you start to think about that and say, okay, so they've made this major commitment. They have these devices all over the place. So you really need things that are reliable, are just going to continue to work, because the cost of rolling a truck to do maintenance on them or something like that is quite high. So you need to choose carefully something that fits your use case and isn't going to cause you problems later, right? And this is working nicely for Infarm. It's just a nice, tangible example, and it's tasty too, by the way. So if you find one of these in your supermarket, give it a try. You know, make a fruit salad with some mint in it, and
I'll have to
be happy.
Look at what cities they're in. I don't know if I have any local or not here to me.
But you mentioned,
I'll come up to come visit you. Should have mentioned, Ross, you're up in Seattle.
I'm up in Seattle, so
you mentioned rolling a truck, but you know, some of our other customers don't roll trucks. Did you know, however, that some of them have actually had to roll donkeys and mules to reach remote sites? Yes. One of the things that we do at Balena is everybody does support. Everybody helps take care of the customers. And when our support tickets come in, it could be a chat, it could be an email. You know, obviously the customer has an issue and we want to do our very best to triage that and get them back up and running. And a customer came in to support one day and said, hey, I'm unable to reach my device. And, you know, we, of course, do our due diligence and take a look, and the device is certainly offline. We can't reach it either. Do a little more prodding and poking, and it turns out it was connected via cellular, but it was way out in the wild doing some environmental monitoring. And, you know, honestly, if the cellular connection drops, no matter what, there's nothing you can do until that whatever nearest cell tower, you know, gets back up and running and is able to reestablish connectivity to the device. I want to say, you know, that in this particular example, though, they also wanted to replace or swap out the SD card on the device. So he said, okay, well, maybe this is an opportunity to make a trip to the device. And I said, okay, yeah, you know, just let me know what it will take a couple, you know, maybe a few hours. I'll be here. No problem. He said, oh, no. It'll be a few days. I have to deploy someone on a donkey. It'll take 3 days to get to the device. And then 3 days to get back on the donkey. So I said, okay, well, my support shift might be over by that point. I'm not, but just email us and let us know when the device is back and we can take a further look at it. Yeah, you know, rolling a truck is not always what our customers do. They may have to roll a donkey.
We should.
And it worked, right? If I remember the story,
and it worked. They just, you know, I had to send out the donkey, but it worked. So we're good. All right. Well, you want to talk a little bit about then? I guess one of the things we mentioned earlier is this concept of prototype to production.
Yeah.
And you showed right there with infarm an end product, okay? In that scenario, like you said, it is expensive to roll a truck. And I can't imagine that the unit itself, the actual micro farm, I can't imagine that thing is too terribly cheap. So you get into a situation where you may develop on prototyping hardware, but then you've got some choices to make about going to production and thinking through the hardware selection process there. Obviously, like we said, budget, workload, the use case, etc. But you have any advice or best practices, or is there anything you can sort of comment on from that prototyping phase?
Sure. Well, let's start by actually looking at some devices and sort of talking through it here. So I'm going to switch cameras. So here we have what, you know, customers commonly start their prototyping with. We've got a Pi 4, which is a great, wonderful device. We love them. They're not really a production device, though. You can start here, try out a bunch of things, make use of the Pi community that's so awesome, find the answers to your questions, make sure it works, and so forth. Do it all for, you know, very reasonable price, which is great. But then when you're ready for production, you're ready to go to 100 or 1,000 devices. What do? Well, there are other devices you can choose. Someone in the comments has already said, well, you're just going to talk about balena fin, aren't you? Well, sure, we're going to talk a little bit about balena fin because this is a production device. So, for instance, it doesn't use an SD card. It uses eMMC, so you get an increase in reliability there. It works over wider temperature range and is just a generally more reliable device. And this is, in fact, what infarm uses inside their systems, is that they have balena fins sitting in there running things. I don't know if they prototyped on a Pi 4 or not, but they could well have and just said, okay, now we're ready for production. We're going to look at what we can choose for production and go there. But there are lots of other choices, too, that you can make.
That's really cool. I did not know that the fin was powering that micro farm.
Yes, fin inside, for sure.
That is very cool.
And this is the Fin CM3, of course. So it's a Compute Module 3 that's inside there. There will be a new version of the Fin with a Compute Module 4, which is going to be very exciting, actually. I'm sure there'll be an IoT Happy Hour about that.
Oh, we sure will.
Yeah.
You better believe it.
You can actually use CM4s now, Compute Module 4s, on the platform. So this is the Raspberry Pi Foundation board. This is the CM4 I/O board, and there's the CM4 module installed on the device.
And that board, like you said, just to reiterate, that is a supported balena device. So you can prototype with that right there.
You can not only prototype with it, you can actually go to production if you choose to. The Pi Foundation does talk about this as a production device. For instance, they've gotten it certified in various countries, as you have to for something that you really want to use in production. So it's a physically large board, and there's some other things to look at. But you'll see not only a Fin 2.0 board using the CM4, but there are other CM4 boards, carrier boards coming out. And this is a theme I think we'll see throughout this, where we'll see a lot of system on modules like this one that can be used on a variety of boards to support some slightly different use cases at least. So that's a nice progression.
That is a good one.
From prototyping to production. We can also look at it in, let's look at it from the context of doing some AI on the edge, for instance, some inferencing. So here we have a Google Coral dev board that's also supported on the platform. And this is actually Google's naming for it, right? So it's a Google Coral development board, and it's in their category of devices that you can use to develop with. They've got a few others there. But if you want to go to production, their suggestion is that you use either their system on a module, or you get a board that has their system on a module already there. So you'll see this board, specifically the Asus Tinker Edge T, that has the Google Coral TPU on it. You'll see that appear in Balena Cloud. It's not there yet, but the intent is that it will be there. So this is, again, another case where you develop and then you go to production.
There's one more option there just to quickly cover. The Coral team also produces a version that has the TPU sitting on top of or on an MPCIe form factor. That MPCIe form factor could then be inserted into the bottom side of a balena fin. So you could, in fact, go out to production with your fin and the added capability of the TPU. I personally have not tested that, but I know that that is something that would technically be possible. And then I see we have a question come in from Arajit. What's the cost of the Asus board? Do you know off the top of your head that Edge T with Coral built in?
I don't know what the suggested retail price is of that device.
I'll go look it up real quick while you're, if you want to continue on, I'll grab a link to it.
I think it's going to be somewhere around 150, but best to find out for sure. Yeah. And to David's point, there are other ways to go to production with Google Coral technology. There is the MPCIe module, which I believe is actually a true a PCI module, so it's not communicating over USB, so it's a fast connection to the host device for that. So there's some nice options there. And then we'll do one more on that stream. So we've got here one of the devices that David had as well. Let's get a little more light on that. So this is a Jetson Nano dev kit board. Great, wonderful device. This is great to develop with, fully supported on the platform. This is the dev kit, so it's the one that has an SD card to work with, which is actually kind of nice for development, to make certain things easier. But when you go to production, you want to use a different device. So this is this is also a Nano, but this is the Nano production module. So you can see it's a system on a module. You can actually use it on the same carrier board, the same base board. But if we look at the back side of that, you'll see that there is no SD card slot on this board, right? So there's eMMC on board, so you get that bit of reliability. Again, you can develop here and then go to production on something like this. put it on this carrier board or one of the many other carrier boards that
there's an entire ecosystem of
absolutely.
carrier boards out there, small, large, and everything in between. They also have different ratings for temperature. They also have different options for port arrangement, port types, et cetera, et cetera. Now, what is this little
You don't have a title.
thing?
Everybody knows.
What is this?
Everybody knows NUCs, right?
Yeah.
Everybody knows NUCs. So this is an Intel NUC. And this is actually one of the most commonly used production devices on Balena Cloud. It's also what people can develop with. So this is a case where your production device and your development device might be one and the same. Great device, and many, 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 many of these on the platform for some higher compute loads.
Let me use that as a hop-off point.
Yeah.
Because higher compute load. So let's dive into that. Tell me a little bit about, I guess the question in my mind is, how do you know that you need a NUC? Or how do you know, quote unquote, what your workload requirements are? Is there any way that somebody would be able to sort of predetermine that? I think the reason I'm asking is because I have seen situations where this actually happened recently also in support, where customers will choose hardware that, quite honestly, is just not powerful enough to run that workload. So how do you know?
Well, you try it. I mean, some things you'll just know, right? But that's kind of what you get from prototyping with things. And we have the opposite of that, sort of in a good way as well, where customers will say, okay, I've prototyped it. I think device X is good enough to use, but I'm actually going to go with device X plus. So I give myself a little bit of headroom. So if I'm going to do some different things, I can do those. I can give you one use case where NUCs are used today, and I think it's a good choice. So we have customers that do things with network security cameras. We'll aggregate them together and provide visibility and so forth, and give you access to those video streams when you need them. And there you may want, higher compute capability. You may be pulling in, 8 or 10 streams from a variety of cameras there. So there's a bit going on, and you may want to do some transcoding for presentations. So you may record in one video format, but perhaps you need to transcode on the fly to present that through a browser or something like that. So that's a case where a bit more compute power can be helpful. And it's also a case where you don't really know what that product might be doing, that system might be doing a year from now. You may want to do some, a whole bunch more transcoding, or you may want to be sending stuff off to the cloud or something. And so having that additional headroom so you don't have to go out to those hundreds or thousands of locations and replace the devices, it can be a smart business decision.
Yeah, absolutely. So the situation I saw recently was an automotive manufacturer is doing some testing on the Balena platform, and they're essentially running their automotive stack. So that includes LiDAR, that includes camera, that includes object detection around the entire perimeter of the vehicle, so on and so forth. All your typical self-driving technologies. They had chosen a product from a manufacturer by the name of OnLogic. And OnLogic produces some fantastic hardware across an entire range of devices. And let's stick with that theme of the NUC there, which is an x86 device. Okay. This manufacturer chose one of the smallest OnLogic devices. And over in Intel land, and AMD has this as well, but they will sell you a chip with one core going at a crawl, or a chip with 20, 30 cores, blazing fast. And there was a big price difference between them. But point being, this manufacturer had chosen a device that used an Intel Atom 3800-ish series. And it happened to be the same CPU that I have right here on this board. But they did not use any AI acceleration. They were just simply using raw x86 CPU, no GPU, no nothing. And quite honestly, that little Intel Atom could not keep up. I mean, it's great on a light workload, but it could not run this automotive stack. And the CPUs were pegged at 100%. It's a quad core device, but it could not keep up, and their services were crashing. Containers were crashing. And the solution, simple fix, was literally go buy the i5 version of the same hardware, and the processor didn't even break a sweat. Containers continue to run. LiDAR continues to run, which is important in a self-driving vehicle. So, easy as that. That was the fix. Literally get a more powerful processor.
Just a processor, or then you need to upgrade memory. You suggest to upgrade memory, RAM.
I think that their device may have had enough memory. I can't remember if they had a 16 gig unit or not. Memory pressure was sufficient. But this brings up a good talking point. A few episodes back, we did an episode on Datadog. Mark, remember you and I took a look at how to use Datadog to sort of gather some metrics as to what your workload is really doing and taxing the hardware. And so this was a situation where the customer, in this case, they're still prototyping. It's great that they caught this now because they don't want to deploy literally what is an assembly line of a vehicle, a million. How many do they build per year, right? You don't want to go build a million vehicles and then issue a recall to go replace something as simple as literally this board. So, some trial and error, but you can generate data to sort of go through your experimentation process.
Yeah, and find out what you need. And to the earlier point, we support 70 device types on the platform today. So you have a wide choice. And since we're talking about x86s, the number is actually greater than 70 because you can choose a whole variety of x86 devices that are likely to work on the platform. You mentioned OnLogic. That's one of them. I happen to have a photo there. They make some amazing devices.
They sure
amazing industrial devices. And you're right, you have a wide choice of how powerful you want in those, which is great to have that choice. And we also support Upboard directly on the platform.
Let me make it a little larger. Hang on. Yeah. Mark, you got it?
Yeah.
There we go. Yep. The Upboard is also
Upboard
supported.
device, and so pretty common, used on the platform as well. I saw there's a question about NUCs don't have GPUs, right? We're actually going to talk about that a bit when we get to talking about AIoT workloads and what's there. NUCs are kind of flexible, so you can do a variety of things with them, and you certainly can get some, particularly now with the 11th gen Tiger Lake, that have they're Intel GPUs, but those can actually be quite interesting.
Yeah,
but we'll get to that. Yep.
So looking at the clock, we are at T-minus 21 minutes ish. So we may get moving on that, but nice try. That was a photo, not a real board. Yes,
that's right.
That's right. But the previous question, or not even question, I guess it was a statement, is power consumption is probably 10x though. So correct.
Yeah.
And let's cover that quickly, and then we can move into, the AIoT use case. So that is absolutely a consideration. Power consumption at 10x, maybe even more, is something you need to think about. Where is the device going to ultimately live? In a car, in a micro farm, out in the middle of nowhere, or in a factory, among a million other places. But knowing that end result, where will the device live, and what are its thermal properties? What are its space constraints? What are its connectivity options? If you're talking about a factory and it's something that's doing some monitoring, maybe some machine vision, but ultimately it's in an industrial setting like a warehouse that you just plug it in. Who cares? Let's assume
Right.
that a factory has adequate power, adequate space, and it's stuck on a DIN rail somewhere. Does it really matter? No, you're probably better off. Yeah, Ethernet.
Power.
Yeah, those are luxuries.
Yeah.
You may not care about that 10x uplift in power. But if it's going to be out in the wild and maybe even running off of a battery that is charged on solar, you most certainly care about the thermal properties and power properties. Have you seen, Ross, any customers, like how, I don't know, how do you determine, I guess, how do you make that trade-off? I guess really, again, some trial and error, or I guess maybe a little bit of choose hardware that fits a certain profile?
From the power comment is valid and correct. You mentioned a variety of other things.
Sure,
so
yeah.
I'll add to that.
Yeah.
There's also environmental considerations, like is this device going to be outdoors and how do you protect it from the elements and can it withstand the temperature ranges and things like that.
Good point.
From customers, we have a few customers that are power constrained, and the Fin actually supports that beautifully, by the way. But it's not super common for a customer to say, hey, this thing consumes 12 watts and I need something that consumes only 8 under load, or 20 and 10 or whatever. It doesn't come up that often. It's more of the constraints of the environment, either in an industrial setting with vibration and possibly heat, or an outdoor setting where you need to protect from moisture and things like that, or just size, right? It needs to be small enough because our device needs to be attached to this other things, or needs to fit inside that, or something like that. Those come up much more commonly than the power constraints come up. But it's absolutely true that there's a wide variety of power consumption among the many devices that we support.
All right. Well, I think we've covered.
And if there is no like a lot of computation needed on the device, what do you recommend? Like, I have something simple, but I'm gonna have like a fleet of devices. Then what's a recommendation? Then it goes to budget, for example, or it goes to.
It can go to yes, if you're really just, maybe it's a gateway scenario where you're really just in the location and you're collecting the bit data and you're sending it up to the cloud. So it's not a heavy compute load situation. We've got a whole variety of devices that can do that. It's pretty common for people to say, just as we covered earlier, let's prototype this on a Pi, and then we'll move to a Pi class production device, like a Fin or something like that. That's a pretty common circumstance. It's nice, it's easy to develop with, you get the support of the Pi community that's out there, lots of hardware peripherals that you can choose and so forth to go with those. Peripherals do come into the equation too, by the way, and knowing what you need to support and which of our device types have kind of built-in support for those can be useful. Like the x86 device types tend to have, generally, especially one of them has more of the upstream kernel tree in it, so you're more likely, if you're plugging in an Intel RealSense camera, for it to just kind of work on an x86 device than you are on a lower powered device where we may deliberately put less of the kernel tree in there, so it's a small image for the host OS and such. So.
Yeah.
And do you see that in these cases, like the total cost of ownership of devices is key, or it depends. No, if as David was saying, if it's a machine that costs $1 million, right? you don't care if it's a $100 or $300 board, right? But in other use cases like the gateway that you mentioned, the total cost of ownership, it plays like a big role there on the board selection, or what's your experience there, Ross?
Yes, total cost of ownership is the right way to think about it. And that's going to include things that we've discussed, like, the board itself. How much does that cost? What does it cost when you do have to roll a truck or a donkey to get there? And that varies wildly, right? If this is more of a device that you can just put in a box and send back and get warranty support on, and that's an easier scenario than sending a technician out to fix something. Connectivity costs can be an interesting part of the equation as well for some customers, that if they're mostly connected by cellular, for instance, they sort of need to budget for that and figure out what that's going to be and what things you can do to manage that cost. And we actually have things baked into the operating system to help with that specific instance where cellular is a big part of what their total cost of ownership is on those. So yeah, you think through all of those things and figure out what the right choice is. And there's no real prescription. You just sort of have to think about what you're doing, who your customers are, and people like me are here to help you think through that.
Absolutely.
Exactly. I always thought that it as well. It's important to see that the technical team, of the company, what are their preferences, right? If they have experience with ARM devices or x86, etc., probably they will be opinionated on deciding what to choose, right?
Yeah.
Or you have seen different.
Are we opinionated? We're happy to express opinions on things, but we support a wide variety of devices, any one of which is good for something, right? Or it wouldn't be on the platform. So there's not like, say, oh, don't use that one, it's terrible, right?
It wouldn't be there if that was the case.
Right? So this is really, it wouldn't be there. We wouldn't do it, right? But there are, knowing what those devices are good at, right, is something we can help with. It can get complicated at times because we've talked about pretty familiar names so far on these devices, but then you get into things like, everybody's heard of Pi's and the Pi Foundation and so forth, but when you get into production devices, and you're like, oh, boundary devices.
Yeah, exactly.
Verisite, right? Those are not part of
CompuLab. A Dart MX8M or a Nitrogen 8M. Those are there for a very specific reason. Yeah, like you say. And I guess maybe that comes down to, this is a good probably transition point into, I guess, segmentation by the industry or use case, because digital signage as an application, let's just choose that one. It's a fairly light workload that's being run. I mean, it's truly just call it a static display, like a menu board at a restaurant would be one, or not so much necessarily an interactive kiosk, but just some sort of like a giant TV monitor with something on it. There's not a whole lot of compute power necessary for that, or the environmental sensing use case, just taking a temperature and humidity reading.
Right.
That's it. And transmitting it, call it once an hour. It's not too much going on there, really. Right. But you also, again, the example of rolling a donkey, you want something that's going to be reliable, because if it's going to cost a fortune...
I'm sensing you may be slightly unfamiliar with donkeys, because they don't actually roll.
Oh. You know what? I'm going to have to do a little research. But no, the cost of, you may save a few dollars to go with a cheaper device up front that may not, quote unquote, be production ready. And I mean, I have a very fond place in my heart for a Pi Zero, but it may not survive well out in the wilderness. Versus something like you said, why is it there on the platform? What is the boundary system's nitrogen or a Verisite? So those are things then that might be.
There we go.
Right. So might be cheaper to just go with something that has extended temperature range or port placement or whatever,
Right.
eMMC or SATA or MPCIe. So I shot JR. They call them burrows. Maybe that's the issue. That is true. We did.
Yeah.
We did.
But it's more
So gotcha. All right. But
Hey,
then
let's get-
thinking about,
sorry.
go ahead.
No. All yours.
Yeah, but then I guess Mark probably calls them burrows too. But then, so thinking about, all right, let's transition from there, from digital signage being a light workload to something that's a heavier workload like AIoT.
Sure.
You showed off a Jetson Nano, which, if I remember correctly, has 0.5 teraops of AI processing power. There it is right there. That's the dev kit. You also showed the production version, which is eMMC based.
Right.
Now, that device runs a CUDA stack. I guess another talking point or decision factor is your application itself. Before you even get to a point of choosing hardware, I guess the conversation really becomes, what are you trying to run? Mm-hmm. Simple as that. Because in the AIoT world, there's a couple different frameworks. That right there and its CUDA acceleration, or I should maybe back up and say, if your application requires CUDA acceleration, that device type right there is the way to start prototyping. And of course, you can then move to production with various devices, as we've talked about. Mm-hmm. But there are other ones as well. What about OpenVINO? Could I run OpenVINO on that
David,
device?
a question about Jetson Nanos, because I think before getting into
Sure.
But because there are like 6 different Jetson Nanos, when do you choose one or the other, like the Jetson Nano Xavier or the? Do you have like a specific use cases to show when to use one or the other?
Well, I suppose that was why I was maybe sort of taking the conversation into step one is, which framework are you using? Which is, well, Ross, you also showed the Coral. The Coral is another that is a TensorFlow based stack. So I guess in my mind, step one is, which ecosystem are you living in? The NVIDIA world, the Coral world, or the OpenVINO world?
Okay.
Now, that's going to immediately narrow down your choice of hardware. If your application uses OpenVINO acceleration, Movidius acceleration, that NVIDIA Jetson Nano will do you no good. You're automatically looking at something that has a built-in Movidius accelerator, a Movidius stick, or if you are living in the, and you're going to be selecting a NUC, or you can, in fact, put a Movidius stick into a Raspberry Pi. There are libraries for that. But, again, if you're living over in the TensorFlow world, perhaps the Google Coral or its various brothers and sisters, like we showed the Tinker Edge T, or a Fin with a Coral accelerator on MPCIe card, are all of the options. Okay, now that helps you choose your starting point and immediately narrow down the scope. But then, Mark, your question becomes extremely, extremely valid, which is, now how do you choose the performance range like we talked about earlier? I don't know, Ross. Do you have any thoughts on that topic of how to choose, like how much inferencing or AI acceleration power you need?
Well, to talk practically from what we hear from customers about things, often when we hear from customers, they've gotten their idea. They've maybe done a little bit of prototyping work on it and so forth. And you're correct, David. By the time we talk to them, they may have already chosen an ecosystem to work with. Could it be the Jetson ecosystem that you're showing off there? The Jetpack ecosystem. Could it be in the Google Coral ecosystem? Could it be in the OpenVINO ecosystem? The good news is we support all of those. Right, so we like to give our customers choices so they can choose from among those. And I think the best answer to the question of once you've chosen one of those, like here, let's bring the Jetson Nano Dev Kit back. Right, as Mark pointed out, we support 6 Jetson device types today. So various Xavier device types, for instance, included in there. So this nice step range of performance, and that becomes a pragmatic question as well, where customers can try those things and see which works, which provides the right performance at the right price point for their application. So again, we support all of those so they can choose. And the community, any of those 3 communities, is going to have some advice for it. So if you're using someone's pre-built model and adapting it, they're probably going to have recommendations or how they've used it and so forth. So for this computer vision model, we find that it works reasonably well for these tasks on a Jetson Xavier NX, like what David has on his desk right now with those. Which is great. So you're not alone in doing this. So there's advice from us. There's also advice from the community that's out there in doing these things. The same is true for some of the other platforms as well. We've got OpenVINO, for instance, so we'll bring the NUC back or other x86 hardware with Intel devices in it. And there's a question earlier that relates to this about GPUs that we can work into this. So there we go. This is sort of like David and I competing to see who has more devices to show off here. And,
No, these I've already shown all of these on previous episodes.
Okay. So you have the same kind of range with OpenVINO. So you can, if you have, say, a Tiger Lake generation NUC, which has more sophisticated Intel graphics in it, that's actually fairly potent. That's quite potent, actually. And you can add to that with Intel Movidius chips, like what David has on the AdLink device that he's opening up for us. And, of course, there's the Intel Movidius stick that you can add to other systems to work with. So you have a nice choice of performance there as well.
Actually, I do not know if we're going to be able to get a look at, now that I think about this. Yeah, well, I'm trying to think about whether we'll actually be able to see the Movidius accelerator on the SOM, but we might not be able to. And that's okay. I'll just continue this here if you want to go on.
Yeah.
Are there more questions in here, Mark, that we should be answering?
Did any other questions come through?
Not from the community, from the audience. I don't know if there are questions.
Ooh, this is a tight fit. I don't know if I should.
What do you want to show?
I don't know if I should go any further. Oh, actually, no. You know what? How do you remove a circular screw? Come on, blurry cam. Get it. There it is.
Wow. Yeah.
Not sure how to remove that one. Wow. So, all right, we're not going to be able to get a look, but the Movidius accelerator is on the SOM. So, but yeah, they come, again, various ranges in performance.
Yeah, I can imagine that as a USB stick. Yeah, probably the bottleneck sometimes can be the USB. Right?
Yeah. Yep.
So,
All right.
yeah, one pattern that I see in of the difference between POCs and wait a sec, and production, it's moving from SD cards to eMMCs, right?
Yep. And let me just give you a good example of that here. So we'll bring this photo back on. So this is Boundary Devices, a Nitrogen 8M Mini. We have thousands of these in use on the platform. And so since all three of us do support, have you guys ever had a support case? Or very commonly, have you had a support case with a Nitrogen 8M Mini?
No, I sure haven't.
Yeah,
Of what?
I haven't
Sorry?
had one. With the Nitrogen 8M, hey, someone write in and say, hey, I've got a Nitrogen 8M Mini and I'm having this problem, right? I haven't had one.
Nope.
Right, and that's exactly the sort of thing you want in a production device. And that doesn't
Yeah.
have an SD card, it's eMMC, right? You want something that's that boring that you don't get people writing in and saying, "Hey, I'm having this issue with it." So.
Yeah. Well, that's right. That's a good one. Yeah. I have too many of like SD cards that get corrupted.
And we don't.
Yeah.
Have you seen a lot with the VeriSite? So now we're in the territory of these production devices that some of you that are watching, since you're professionals, may have heard of, but sometimes our customers have not. The boundary devices that we just showed, and VeriSite that we support a number of their device types, right? And I don't see tons of questions about VeriSite devices coming in, and we have lots of those on the platform. I mean, part of that's because those customers with big fleets tend to be more sophisticated, but it's still notable that they're using these production class devices and they just work.
Yeah. They are very solid. Yeah.
All right. Well, any other topics we haven't gotten to? We talked about budget. We talked about workloads. We talked about AIoT and Kyle. No, I did not get the USB screwdriver yet. I think we are pretty good. Anything else, Ross, that you can think of, or Mark?
No.
Well, that's
one of the lessons learned. Yeah, it's go to a solid and production board. Yeah, avoid SD cards.
Or at least get high quality ones.
And if you're trying to build a fleet and you don't know what to choose, you're always welcome to contact us and ask, and or go to your community too. Like if you're doing some AIoT stuff, your community is probably going to have some thoughts as well. But we're here to help if you have questions.
Yeah, just reach out.
Yep.
Yeah.
Okay.
All right. So I think we are good when there are no more questions.
No, I think we got everything. Mark, you want to close us out?
Yeah. So, we have a couple of things to mention, but today we saw an episode about all different hardware that you have from going to POC to production on different use cases, different budget, different workloads, etc. So, that was really good. Thank you, Ross, for coming.
Yes, thank you, Ross.
This is fun.
All your whys.
Mm-hmm.
About this topic. It's really, really, really interesting. And I think we can mention before disconnecting that Balena is still hiring. No, we have 4 open positions.
Yes. I'll put the link in.
Balena Etcher maintainer. So if you like our Balena Etcher, we are looking for a maintainer, front-end security engineers, and then design your own role. If you have special skills that you think you can help us with your superpowers.
Yeah, superpowers is a good way to put it. Now, Mark, I think you have some breaking news also. Is there a special announcement you'd like to make?
Sure, yeah. So we are planning breaking news.
Breaking news. Yeah, we need a Giphy for that.
Exactly. We are planning for next Thursday, 13th of May, at I think it's 2 p.m. UTC, our next release party, release party number 6. So if everything goes well, and it's on our calendars, so we are gonna iterate Balena Hub, and we are gonna iterate it in order to create, the first open fleets. So on Thursday we will be here releasing, parting and releasing the next iteration of Balena Hub. So looking forward to see you all here.
All right. Well, 2 p.m. UTC sounds like bright and early for me. So I might have to join in a bit later. I'm not so sure about 2 p.m.
No, sorry,
UTC.
12 UTC.
12? Wait, that's even worse.
Yeah.
All right, that's even worse. We'll see what time I wake up and join. But yeah, looking forward to release party. That is number 6, like you said. And if you've seen the previous 5 episodes, you know that that's where we build a feature and deploy it live. So from end to end, usually takes a good 6 to 8 hours. And we go through our entire process. They're pretty cool. So that is set for Thursday. We will, of course, post that on social media, get all the links out for folks to join in.
And see you next Friday.
Yeah, sounds good.
All right. Well,
Okay.
in that case, we'll see you hopefully Thursday at the release party and Friday for IoT Happy Hour. All right. Bye, everyone.
Have
Bye,
a good
everybody.
weekend.
Bye.
Thank you.